Hi everyone, today we're going to talk about what the sine and cosine functions do, a little bit of what their wave looks like. We call it a sine wave and a cosine wave. But to get started, I want to look at the equation y equals the sine of x. Now in any equation, if you're trying to graph it, you can always make a t-chart. Now why did I choose these points? Well, on our unit circle, 0, half pi, pi, 3/2 of a pi, and back to 2 pi are kind of our areas that we're going to focus on whenever we make a graph. So sine at 0, remember that's your y value, is 0. Sine at half a pi, again it's your y value, is at 1. At pi it's 0, -1, and 2 pi is the same as 0. So if we were to sketch a graph of what this would look like, we're at 0, 0. At half a pi, we're at 1. At pi, we're back to 0. At 3 pi over 2, we're at -1. And we are back to 0. And we're going to look at these graphs more in detail next week. Okay? So this is what we call the sine wave. Now, just like a circle goes on forever and ever and ever, guess what? This sine wave goes on forever and ever and ever. And in a lot of physics classes or different things, when you hear about sound, it's measured kind of in the sine wave. All right, let's look at the cosine then. If we look at y equals the cosine of x, at 0, the cosine of 0, now this is your x function, so it's a 1. At half a pi, it's 0. At pi, it's -1. At 3/2 of a pi, it's 0. And 2 pi is back to 0 pi or 1. So this time, the wave starts as high as 1. It's 0, goes to -1, back to 0. And again, it's still curving, and we're going to talk about that more in detail. But a complete cycle is done in 2 pi. Again, think about that complete circle is done at 2 pi, and then it'll repeat itself. So today we are going to talk about evaluating trig functions using its period as an aid of 2 pi. Well, when is it done? When is the circle done? At 2 pi. So if we evaluate the trig function using 2 pi as an aid, basically what we're doing is we're looking at keeping these as like positive and negative coterminal angles. So if you look at finding the cosine of 7 pi over 3. Well, if I take my unit circle, I can't find a 7 pi over 3. Well, why can't I? Because 7 pi over 3 is bigger than 2 pi. This is the same as me saying 2 and 1/3 pi. So we've already gone around the unit circle once, and now we're at 1/3 of a pi. So when it says to use 2 pi as an aid, we want to take out any extra rotations and just look at it within the one rotation. So if I were to take out this extra rotation, I have to take out 2 pi. So now I'm at 1/3 of a pi. Well, can you find the cosine of pi over 3? You sure can. Pi over 3 is the same as 60 degrees, and cosine is my x value, so my answer is 1/2. All right, let's try another one. Find the sine of -7/2 pi. Well, again, this is the same as -3 and 1/2 pi. Well, I can't find that within 2 pi. First of all, I have to add 2 pi, but I'm still negative. So if I add 2 pi more, so I've actually added a total of 4 pi, now I'm in the positives. I'm between 0 and 2 pi. I can find the sign of half a pi, and when I take out my unit circle, I find half a pi. Sign is the y value, so the answer is 1. So on your own, I want you to try finding the cosine of 19 pi over 6. 19 pi over 6 is the same as 3 and 1/6. That is too many, so I'm going to take out a 2 pi, and now I'm left with 1 and 1/6 pi, which is the same as 7 pi over 6. Now I can find the cosine of 7 pi over 6. When I use my unit circle, cosine is my x value, so that is negative square root 3 over 2. Try one more on your own. Find the sine of negative 21 pi over 4. Negative 21 pi over 4 is the same as negative 5 and 1/4. I'm going to have to add 2 pi, but that still keeps me negative. If I add another 2 pi, that still keeps me negative, so I'm actually adding a total of 6 pi right away. And when I take and add another 2 pi here, I have a positive 3/4 of a pi. So I actually added a total of 6 pi's. Now I find the sine of 3 pi over 4. Sine is your y value, and 3 pi over 4 gives me square root of 2 over 2. So basically you're just trying to get it in between 0 and 2 pi by adding 2 pi or taking 2 pi away.